I'm going to test something out here. Any questions? Okay, good morning. My name is Adam Lewis. As John said, I'm from the Security Technologies team with the Chief Technology Office's Motorola Solutions. And hopefully, as you gathered from the video, I'm not here to talk about cell phones. We used to make cell phones. We divested of them a long time ago. What we do have at our core, though, is a first responder business. And I am really excited, actually, to be here today to share with all you guys the way we are, I would say, using the bleeding edge of Identity 2.0 technologies to enable some very cool mission-critical work group communications for first responders, for police, fire, and paramedics. You could tell from the video, the police officer of the future and even today is going to be a lot different than what your traditional walkie-talkie radio was doing, some time ago. In fact, first responders are really riding the same kind of waves of depersonalization, mobile broadband, cloud, wearables, and API access that a lot of other communities of interest are. The difference is that we're using this actually in a way that is really bringing situational awareness both to the responder and the back-end command center. So, we have the agency today is now going to externalize APIs that will go out to the first responder directly. So the first responder will be having mobile broadband access to contextual awareness back at the command center. But it doesn't stop there. They're also embracing the whole cloud that everybody else is. So they're going to be accessing the cloud. And there are going to be people like the FBI who expose criminal information records through the CIS information system that they will need to access in real time. And countries around the world are building out national level first responder broadband networks. So here in the United States, it's FirstNet. Every country is doing their own at a nationwide level. And there are existing law enforcement federations in progress today. And this first responder is going to have to connect to every single one of these, all right? And it's an identity conference, so there's two things we got to talk about. This responder, when they connect these APIs, every API is going to have to know two things. Who's requesting it, and what are they authorized to do? All right, so this is a whole lot of information flowing. And in our vertical, what we cannot have is this. So, I mean, how many feel this way on their own, right? Now, try doing that with your gloves on. Okay, so this is in a nutshell, right? We all know this problem. If all those different silos solve identity independently, we're going to come up with a complex solution. It's going to be, an obstruction to interoperability. It's going to be insecure. It's going to be really bad. So public safety needs an identity ecosystem that has to enable centralized credential management, single sign-on, and this one is huge. Migration path to strong authentication. If any identity ecosystem that does not pave the way for strong auth is in my mind, dead on arrival ecosystem. And it has to be built on standards, because anything not built on standards is going to be non-interoperable and non-secure. Okay, so I'm going to challenge, if Brian is still here a little bit, I'm going to say that NAPS is very real to us. We're running forward with it. A little disclaimer, what you're going to see here is NAPS is over here, right? Various stages of maturation. We are implementing this actively today. We are shipping it this year. So we are doing something very real, and there's going to be a period of synchronization where NAPS matures, our implementation matures. We are building a token agent. We have partnered with an identity company to provide the NAPS endpoints. But I'm going to show you today how we are using this. So here's my question to you guys. 6 a.m. Where is your first responder? Chances are they're in the locker room. And the first responder of the future is going to suit up with a whole lot more than the uniform. They're going to have a series of wearables around them, from heart rate sensors, smart gun holsters, visuals, very connected. And our first responders, they may have personal devices, but we still have a fleet system where in the beginning of their shift, they run in and they grab their phone out of a charging system. And this phone has to be personalized with who they are. So it's about 6:10 in the morning, they proceed to their vehicle, and they go to log on to the device. And this is from our community here, where things become very, very interesting, and the crux of the presentation gets going. So here's our responder, and they go to hit that login button up there, and then all kinds of really cool things start happening from a NAPS point of view. So Brian talked about the token agent that will help to bootstrap all these tokens to access these services. So when they hit that login, a token agent is going to use a user agent. It could be the web view that he encouraged not. It could be an external web browser, but that user agent is essentially something that can speak HTTP and interact directly with the user. So when we hit that authorization endpoint, the authorization endpoint is going to send back some kind of HTML to the user's phone. Now, this is a really, really, really big deal, because this is what's giving us the migration path to strong auth. If that token agent, if that had to understand every form of authentication, we would never get past the password. In one of the keynotes this morning, you heard them say the answer is simple. We need strong auth. We just can't get there. And one of the reasons we can't get there is, if you guys know how hard it is to get an application developer to make a change in security, it's really hard. But because of this model in NAPS, which really is building on OAuth and Connect, the client is completely abstracted from the authentication method. So today, that might be showing password, but with the configuration change of that authorization endpoint, that suddenly can become an RSA token. It could be smart card. It could be Kerberos. It could be FIDO, right? We all want to see FIDO happen. And so this is just huge, right? We have to solve this problem, and this is going to be the building block to make it happen. Anyway, the user hits the submit button. It goes up. The code is returned to the token agent, which is then exchanged through a token request message to the token endpoint, and you get back your actual access token. And this is all HTTP, very light, very simple, very developer-friendly. The token agent is then able to use this access token to hit an app info endpoint. And the app info endpoint is able to send back a whole bunch of application metadata tailored to this responder to give them a user experience. For example, it could load up all the applications that this responder is authorized to use. Thank you. All right, 6:15 a.m. Remember all those wearables they put on? Those wearables all need to communicate things. So you can imagine that this first responder has a personal area network service running resident in the background on the device. And once they've logged on to that token agent, the token agent sends a notification message to that PAN service alerting them that a user is now logged on to the device. At this point, all the wearables begin communicating with this personal area network service. The personal area network service, the PAN service, wants to take all this information, the heart rate, what the user is seeing, contextual awareness, and it wants to send it up to the back end. But this needs to be secured over an API, of course. So the PAN service goes to the token agent and says, I need an access token to communicate with the back end. The token agent uses the refresh token it obtained in the bootstrapping process to go back to the back end and request an access token, which is then returned to the PAN service and able to access the back end. At this point, this officer pops up. He is now live in Command Central. All right, everything, his heart rate, his location, his presence, everything is known about this. All right, so this is going to come into play later on. All right, later on duty, 9:17 a.m., a partner of his is responding to a shooting incident at another scene. This responder gets out of his car, presses the emergency button on his radio, which causes his in-vehicle camera to automatically begin streaming live video back to the agency backend. The home agency then is able to use that responder's location context that was sent in the previous scene to send video notification alerts to all first responders in the vicinity of that shooting. They get the notification, and to click it to access to see what that first responder up there is seeing through his in-vehicle camera. Once again, a token is requested. The token agent goes up, asks for the token, gets it back, passes it back to the real-time video application, which then sends it up to the back end, and live video begins to stream to that responder's handheld. And you notice in none of these cases is the responder being asked to enter another password. Okay, 1235, routine traffic stop. They want to use their native mobile application on their mobile broadband phone to access a license plate lookup service provided by a cloud-based SaaS provider. So in this case, the flow is a little bit different because his agency is no longer authoritative for that API. They're no longer hitting a home agency API, but they're hitting a cloud service API. But the records lookup application will nonetheless go to the token agent, which will go back to the home agency NAPS server. This NAPS server then sends back a AC/DC assertion back to the token agent, which sends it up to the authorization server, the OAuth server in the SaaS provider. Now, this is important because this ACD token is an assertion. And this is, I have a typo here. It's not an ID token. It's an ACDC token. But the assertion will identify this responder as being a sworn law enforcement officer. All right, so it has some information about this. And this way, the SaaS-based license plate lookup system is able to not really care so much who the user is, but know their attributes. And we want to do a lot of attribute-based access control. And so once he finds out that he is the first responder, he's able to return a local OAuth token, which is then passed back to the records app, and he's able to access that driver's license and find out information about the driver. Okay, so this is a way that NAPS can be used to federate it across native applications. All right, 6:15 p.m., excuse me. All right, another seemingly routine traffic stop, but this one doesn't go so well. The person he pulls over begins to flee, and the officer begins a foot chase. He wasn't expecting this, so he starts running. He really has no time to hit his radio or call for backup. But during the foot chase, all those wearables go into action. The heart rate sensor he's wearing uses the access token previously obtained to send a notification up to backend Command Central again, where it's popped up on dispatch alert, and the dispatcher is able to use the contextual awareness from other first responders to dispatch first responders close to them for backup assistance. This all happens seamlessly. Finally, 7:10 p.m., sorry, it's morning here, keep going that way, 7:10 p.m., he's at the end of his shift. He wants to access a web server, a web page, provided by NEAF. NEAF is a real-life federation of law enforcement agencies. It stands for the National Identity Exchange Federation. And this is a kind of legacy SAML-based stuff. So how does all this, real cool OAuth light stuff work with SAML? So it turns out there's a, one way you could do this is to have kind of a native app icon that when you click this icon, what it does is it goes to the token agent, and the token agent goes off and obtains an access token. Okay, just like the other steps. And then what the web launcher does, well, it'll actually launch something. It could launch Firefox. It could be a web view. Depends on how you want to implement it. And it takes the access token, feeds it through the web browser to an init SSO pinpoint on the NAP server in the backend. The NAP server uses this to authenticate the responder and dynamically generates a SAML response that goes up to the NEAF server and logs him on using SAML. Finally, it's the end of the shift. The responder has to log out because this device will be shared. He wants to put it back in the charging station. Log out is interesting. Still working on it. Kind of thoughts right now are that they will hit a log out button on the, the token agent, which will provide a UI. And that log out will send notifications to both the backends, to the think of a fan out, log out notification system. And at least that's how we're imagining it. We're waiting for the standard to speak more on it. We will update to conform with the standard as soon as the standard gives guidance on it. And that's it. So second time, any questions?
Token agent and evolution of the authorization ACA that was spoken about 3-4 years ago, I think.
Yes. Yes, yeah, NAPS is the kind of more standard word for AZA. AZA was a early implementation of it. Oh, hold on, sorry.
These are not a use case, but these are the actual implementation.
So we are at various degrees of implementation. We are implementing token agent actively. We have a first implementation of it. We are shipping it this year. The NAPS end server is real. We're using an early implementation.
They're doing this just for your entertainment.
I thought they were trying to get you some exercise. Yeah, so we're actively building this out. So we have the standard is in one state. There's a lot of flux. We are personally implementing the token agent, and we have partnered with the vendor to provide the backend NAP server. Each one of those is in various stages, but this is something that we are actively shipping this year.
I'm curious, given that everything's in evolution, how are you sort of managing that evolution? I mean, it sounds like you're a bit of more of a closed ecosystem, so you have your fingers on all the pieces. Is that correct? Or are you actually having to manage different pieces of the stack being on different incarnations of NAPS as it continues to evolve?
No?
Yeah.
It keeps.
The dispatch has now been notified of my condition.
So that's a good question. It's kind of the latter. So certainly as a solutions provider to public safety, we do make a lot of the components. So we make a lot of things. We make SaaS apps. We make public safety phones, not the consumer phones. But we are not the end all be all. So the token agent, for example, is software. It will run on a BYOD, and we do provide backend APIs. So obviously, with our APIs, we have the ability to move and adapt lighter. We also have the next stage in evolution is we're trying really hard to foster an identity ecosystem within public safety, which means going to partners of ours. You got to kind of get this moving, right? And saying, hey, this is what we're doing. We're really excited about this standard. This is going to do all kinds of great things. We are with group. SA6 is the working group that's been set up to address first responder concerns, since first responder is going to be getting dedicated LTE access in a lot of the countries around the world right now. And so we are pushing a NAPS standard through SA6 within 3GPP. So we're to open this up far beyond us. We obviously have the most control to do things where it's our product, but we're trying to make it well beyond just us. We're trying to create a vision. Within the United States, FirstNet is the evolving ecosystem for public safety. And we have been extremely vocal in promoting and trying to advocate and evangelize this approach for FirstNet. And if FirstNet adopts it, then it will become a public safety-wide standard. So we're trying.
More questions? Oh, you're in.
Just to clarify, your mobile phone going to be hosting all the apps for the wearables, and then
what we have is it's kind of I think of it as a wearable hub. We call it the PAN service. It's an intelligent middleware, and what it basically does is it communicates through the device API. So it could be Google or iOS, and it kind of aggregates all the information. The holster. We have smart holsters. So when the gun is pulled, this holster automatically sends notifications to the service, and that PAN service will send up event notifications. So again, that the responder doesn't have to worry about even calling for backup in this case. So it aggregates, it acts as an aggregation hub for all this, and it takes all of it, pushes it up through context APIs into the back end. To answer your question? It's a single service that aggregates information from all the wearables and. Yeah, that was when the PAN service, our hub, our wearable hub, it requests a token from the token agent, which uses the refresh token obtained previously. Yes. Okay. Yeah. Sorry if that wasn't obvious. Yes, it's a background on the phone.
Somebody over there.
So is a registration service for the personal area network in scope for NAPS standardization, or is that are we going to have multiple standards eventually there as well?
Test? Hey, I'm live. Okay. No, that's not in scope of NAPS. So that PAN service is just, from our point of view, it's a native app. And basically our app is subscribing basically to NFC and Bluetooth type. So Bluetooth have their own profiles, right? So these are really going to connect in through the phone. They're going to pair with the phone. But then this PAN hub, this aggregation hub, is basically subscribing to all these Bluetooth events and then aggregating and sending them up through an API that we've defined. So it's from the NAPS point of view, it's simply a native app running on the device that requests a token through the token service, token agent.
Okay, last question.
Was there any thought into like the networks this runs on? So I'm a first responder, let's say major disaster happens, cell towers are down. Is the technology still useful, like maybe offline mode? I don't know.
Am I live? I'm good. I'm so glad you asked that question. It's a loaded question, and this is the biggest thing that differentiates mission-critical first responder use cases from traditional commercial. We have to build out the 5 nines. And so in traditional first responder use cases, if you lose a tower, the radios begin communicating back to back. We have a lot of work going on an incident scene where a lot of these servers, so if you do have a big blowout, if you have a Hurricane Katrina or 9/11, when the Minneapolis bridge collapsed, the first thing that happened was every cell tower jammed. First responder systems, every single communication went through. So it is a problem when we start building on commercial LTE. But the thought is we have basically command vehicles that can basically set up LTE sites on site. And so there's a whole lot of work going on right now to take that equivalent radio experience and bring into broadband. So we basically have a command vehicle we drop in there and provides blanket coverage to the entire area if the towers are out or we need additional capacity. Mobile cloud or mobile network. Exactly. Yeah. I think I'm done. We lost our moderator.
I just saw the next speaker running to the back of the room, so I think he may have some personal issue to take care of. Back soon. I don't know that he has that wearable currently attached. You'll have to ask him, Justin. Okay.